We're going to talk about Amplify Generation 2 and also a little bit of generative AI and how it helps you to actually create infrastructure and applications in an efficient, very efficient manner. My name is Felipe. I'm a software engineer at idealo. It's been 2.5 years. And I currently work at the mobile team at idealo. And therefore, actually, the reason that I'm here is because I was thinking what I could, if I could start from scratch our mobile application nowadays, how I could possibly tackle this challenge. And therefore, I came across Amplify Generation 2, which actually was announced December last year, and it's currently in preview mode, so it's still not released. And actually, I really like the idea behind it, and I think it's worth it to share with you what you can do with that. So initially, I thought about giving this talk on my own, but then I decided to actually invite a special guest here tonight, because without this guest, actually, maybe I would not be able to talk about what I'm talking here tonight. And therefore, unfortunately, she cannot make it today because she's very busy. So she actually is going to attend it remotely. So I actually invite Alicia to introduce what we're going to talk about. So Alicia, would you mind to come and say some words about the talk, please?
Sure. Hello, everyone. My name is Alicia Iris, AI for the close ones. Are you ready to talk about Amplify Generation 2 and Generative AI? Did you know that AI has been around since the 1950s? Early AI systems were used to perform tasks such as playing chess and solving mathematical problems. Nowadays, AI is already all around us, from voice assistants and recommendation systems to space exploration missions. I hope my dear colleague Felipe, who is a very kind, sagacious, hilarious, handsome, and super humble software engineer, can live up to your expectations tonight.
Very kind.
And motivate you to explore new things in this exciting area that everyone is talking about. Sit back, relax, and most importantly, have fun.
Thanks, Alicia. Very kind words here.
Thank you.
She can get over the top sometimes. All right, so traditionally in the cloud, actually, in the past years, in the beginning, the way someone would probably start implementing some infrastructure could be maybe something around having some EKS clusters, or maybe some ECS service, hosting some applications, for example, in Docker containers. And as you can see here, we have a lot of different components. You don't have to keep track of everything here, but you get the main idea here. You have a lot of different components that you have to have knowledge on that and be able to implement it in a secure and scalable way. And that's a lot of things to keep in mind, right? And especially, let's say, if you're a solo developer, entrepreneur, it's a lot of things to start and code the application until you get it live in production. So with Amplify, actually, the idea is to make it easier for developers, including front-end developers, for example, that don't have deep knowledge on backends or server-side language, to deploy their applications also in a secure way and very efficiently by abstracting the infrastructure layer from the developers. So they could focus mainly on writing the applications. So as you can see here, Amplify, for example, focus on serverless mainly. And you see that you can easily actually deploy infrastructures that would have out-of-the-box AppSync, which actually is a sort of API gateway for WebSockets that can manage your WebSocket connections and make it easy, for example, to have applications that synchronize data even when you're offline in your clients, or have subscriptions with PubSub. And yeah, it's a very powerful way to have GraphQL exposed to your front-end applications. And you can plug things directly like DynamoDB and Lambda functions. And another important thing is that also focus on language that are familiar for front-end developers, like TypeScript and JavaScript for the backend, also reducing a little bit of the cognitive load for developers. So what exactly is Amplify, right? Amplify is not only about infrastructure, but also it's about everything that you would need to build your full-stack application. So that includes front-end libraries that enable you to easily have authorization and authentication flows without having to code everything on your own, including the forms. But it also involves tools like you're going to see the CLI, where you can basically deploy infrastructure and generate code for application. We're going to see all this here. And how does it deploy and make it easy for developers to implement the full stack application? So basically, you have these 3 important blocks that Amplify focus on. You have the backend. So basically, you have an easy way to configure your infrastructure. Then you have the hosting services from Amplify, where you can easily manage your CI/CD deployments and deploy different branches, protect them, have preview branches, and so on and so forth. And you have the UI service and UI components, for example, the libraries that I mentioned, or also Amplify Studio, where you can, in your console, without any code, generate forms and then export them in React components, for example, or Swift. You also can basically design your data model also in Amplify Studio without having to code anything. So these are the libraries that Amplify supports. As you can see, all the major libraries and frameworks, languages and frameworks like JavaScript, React, but also for native applications, you have the support for Flutter, Android, and Swift. This is an example of the CLI. What you can do, you can, like I mentioned, deploy branches, deploy environments, and basically also generate the code for your API for the data models, so you don't have to code anything on your own. Everything exported in different language, like Dart, like TypeScript, and then you can directly plug into your front end. And this is how the hosting looks like for generation 1. So you can easily have your GitHub repository connected here and basically have normal CI/CD deployments supported by Amplify. And also important to mention, you can have server-side render applications, SPAs, and so on and so forth. So yeah. And this is how Amplify Studio looks like. So basically, as you can see, someone can, basically UX designer can create the forms and then export this easily to front-end applications. So all those things that I showed is what Amplify provides you. So we are talking here about Amplify Generation 1 so far. So we're able to compare with Generation 2. So then what's the problem with the Generation 1 that actually made AWS to think about having a Generation 2? So basically a lot of developers were complaining about the complexity. For example, you have really a lot of different configuration files in order to abstract this complexity for the infrastructure, but it came with a price that it made very hard for developers to understand what was behind this configuration, and also hard to extend this outside of the common use cases. In addition to that, deployment process was not so optimal because it would take time actually to deploy this infrastructure until you can test the code in the front end. You had no isolated environments, so it was hard for the teams to work together. Yeah, and it was difficult to understand this abstraction layer. With Amplify Generation 2, actually, the proposal is to focus on a code-first experience. So basically, you have the support for TypeScript for defining the backend. You have a way more simplified file convention, so it's way simpler to understand what's going on. And because it's built on top of CDK, which is how you would deploy infrastructure using AWS standards, so basically this generates cloud formations in the end, but you have the possibility to integrate with a CDK in case you need to integrate with other existing services. Also have the capability to provision sandbox environments per developer, so it makes it very easy for you to work on your feature branch and have everything that you need deployed, and then once you're done, you can just destroy. It's very quick, and then you save some cost that you would not need to generate. Also, it was extensively trained with generative AI, so you have a very good support for Code Whisper. You have they are working on a unified management console for managing all the services, and besides that, you still have a nice CI/CD integration. Yeah, that's how it looks like. For example, here on the right side, you have the definition of your data model. So sorry, you're going to see a little bit of code, but not so much, I promise. And instantly you have the feedback for your front end on the left side. For example, as soon as you add some field that is required, you already see in the front end that this field is not required. You have the validation. And with that, it makes the development flow way more fluent for front-end developers, for example. This is how it compares with Generation 1 regarding the file convention. So on the left side, you have the workspace from Generation 1. On the right side, you have the workspace for Generation 2. As you might see here, I'm not sure if it's too small, maybe yes, but you basically have one resource for taking care of authentication authorization resources, and one resource for having your data definition, your data models, and basically the backend TypeScript file where you connect everything together. And I'm going to show this a little bit more in details later. Pricing, right? Very important. So basically everything that is UI related here, like the libraries, the CLI and the Amplify Studio, everything's for free. So don't pay nothing for that. And for the backend, it's just normal pricing from AWS. You pay as you go, so you can start for free. And then you basically pay per build time and storage and transfer. So just like any other regular service from AWS. However, watch out, as Generation 2 is still not generally available. If you're thinking about using for your production workloads, you might want to wait a little bit, because there are still some missing features, like custom domains. You would have to have some workarounds to do it. Also, there are still some bugs there, some features missing, and also important things like global secondary indexes for DynamoDB is also currently not supported, but it will until the general release. So yeah, just play around, check it out, keep an eye on the GitHub repository, and there is a really great community also to clarify any question. They are super quick, super helpful. So if you're considering to play around with that, I really recommend for people that are just doing some prototype, some fast prototyping, and yeah, check it out. All right, now we're gonna talk about something that it's the first time during the day for the idealos that are here that heard this during the entire day, but we're gonna talk a little bit about generative AI. Because what does generative AI has to do with Amplify? Actually, if someone has to guess, no guess, absolutely nothing. So the reason actually that I decided to introduce generative AI here is because, like I mentioned, I wanted to think about how I would approach the development of such application nowadays if I would start from scratch. And I want to build it in an efficient way. So in this case, I took a use case. I really love traveling. So whenever I have to study something, I try to connect with something that I really like to do. So I thought, okay, I want to build a travel app, for example. And if I had to create the content on my own, this would be crazy. It would take so much time, and I would not be able to really focus on other things and maybe not finish it so soon. So I thought about some use cases where I could use generative AI to cover some of these use cases. I'm going to demo later. But just to mention, that's how I connected these topics together. So I'm not sure if I'm familiar with AI, like someone already used it before, or, all right, cool. So basically, fundamentally, you have these foundation models which are trained on large amount of data, and they enable you to basically create content out of existing content. Yeah, there is a whole, actually there are several different ways to do that, but basically you can generate text out of text, you can generate audio of text, you can execute tasks actually, and orchestrate services using AI, and I'm gonna show that later.
Hey,
what's up?
I just would like to bring yet another couple of interesting facts to you. Did you know that ChatGPT-4 has been exposed to the equivalent of almost all human text in terms of number of words? Fascinating, right? Check it out how much it compares to what an average person reads and hears during their entire lifetime. This allows such models to have a vast knowledge on several different topics. It's all about data. Not just any data, but data with quality and in large amount. So apparently size does matter after all, right?
I have nothing to do with that. All right, so moving on, we have here like, this is just for you to have an idea of how the models are evolving nowadays, right? So here you see all the different providers, the largest ones like Google, Meta, Hugging Face, and here you have like all the different models for each one of the providers. This model have different sizes. They have basically different use cases where they fit better. So you really have to check it out and compare them for your use case if you're thinking about using. Another important thing to mention is actually that everything here really depends on data. So it's really important that you make the data available and don't have silos for accessing such data, and that you make it easier for such systems to connect, and then based on your own data, provide value. Because of course you can just use it, the general model that everybody does use, but the important thing actually is when you start using this with your own data to provide more value to your customers. So these are some use cases that just to give some idea of what companies are doing nowadays. Vodafone, for example, is using this for a really nice use case. Imagine that they have so many customers calling in, complaining about problems, and dealing with that manually, it's insane, right? So basically they create systems that can basically summarize all these calls, transcribe, and then give a nice periodization of such problems and a nice summary for someone to check it out. Idealo is also using this for a different purpose. For example, we saw today in the talk some example about creating smart comparisons for product, but also for extending the product catalog by converting offers in a smart way to products. Really quick example from AWS, they have this Amazon One shop where you basically don't need to bring a wallet, don't need a cart for buying things. You just enter the store, and with the palm of your face, you basically pay for everything, and you enter the shop, and you have your basically your customer card, right? But for training this device, they really have to have really high confidence that they can identify the right palm of the hand and match to the right customer. And to train such device, actually they didn't imagine that you really need a huge amount of data for different hands with rings or stitches and things like that. So what they did, they extend real data with synthetic data to train such machine, and then have high confidence that you would have a secure system. And the list goes on. So Klarna, for example, implemented shop lanes, where basically you just point your camera to some product and basically gives the best offer on the platform. All right, not everything is flowers, right? So basically, if you see here, a query on ChatGPT can take up to 100 times more energy to execute than a Google search query. So this is really a lot. Or for example, Llama 2 training took something equivalent to almost 7 flights round trip from Berlin to Paris. So this is really a lot. This is how the chat completion API from ChatGPT looks like. So basically, when you interact with the prompt on ChatGPT, behind the scenes, you would have something similar to this. So in the API, you can select the different models. You have many different models, and then you can give a role to the system and tell how the system should behave. And then you have a history of messages that the user can exchange with the system, and then have an output out of that as an answer. So that's what you can do with ChatGPT, but then you have things way more powerful than that. So for example, AWS Bedrock. I found it out and I really fell in love with it. Like it's crazy. So the first thing is that it provides you with a fully managed platform for basically managing your AI things. So the first thing is that it scales, right? So you can basically choose different models and then use one API and compare which model performs better with the data set that you have for your use case. So this is really powerful. In addition to that, you have features like you can easily customize your foundation models. You can fine-tune them, or you can have these reg patterns to basically integrate with other services like Lambda functions, your own databases, your own repositories of data, in order to provide the information that your customer is looking for or that your service is looking for. So we're going to see that later. Yeah, and most importantly, you can also place guardrails on what the model should do and should not do. So these features are also in preview at the moment, so they're not available to everyone, but I believe they will be available soon. So you can, for example, limit what use case your model should answer on. So if you're a bank, you can limit and say, please don't give any financial advice to the customers. All right, so let's see how these things connect all together. So I would like to show you this, this application. So basically, this is a Flutter application, and the idea is to make this you cannot see, so of course. So here we have an empty Flutter application, which I built using Amplify. And basically, you have here the authentication form with all the different social login providers, and everything is provided out of the box by Amplify. You basically just have to integrate with your API keys and so on. And also the authentication flows are also implemented out of the box. You can customize this form, so you don't have to use these forms, but you can just hook into the authentication flow and then have your own forms behind that. But you can also easily extend this and add additional fields in case you need phone number, for example, or you can also translate, you can change the branding, the colors, and so on. So makes it really easy. And I'm going to show how that looks like in the code. Just, it's a bit tricky with the mouse here. All right, I hope you can see here. Absolutely. Looks better? Cool. So if we go down to the back end here, so this is basically a monorepo, Amplify, and here you have, for example, all the authentication and authorization resources. So those are all the line of codes that you need to provide resources like Cognito and identity providers, and integrate this with your social login providers. Also, if you want to add MFA, it's actually just a couple of lines as well. So it makes really easy to just extend with multi-factor, and it supports like authenticator apps like Microsoft, but also SMS. This is how the DynamoDB's tables would be defined. So basically, you have here a destination model, different attributes. By having the required keyword, you can say which fields are required. You can have authorization at field level, if you like. But also you can have the authorization at the table level like this, just having a keyword. And then you can protect it for specific groups. So only admins can do tasks like read, write, and so on. And you allow unauthenticated users to just read data from it. So it makes really easy to integrate authentication as well. So you don't have to code all these things on your own, just few lines of code. And you can also have things like control at owner level. So only the user that created this record has access to actually access this record. All right, so let's have a look on how you could benefit from generative AI, right? To play around with this application. There we go. It's inverted my mouse here, so it's also a bit tricky. So first of all, let's register a user just to try it out. That's my personal email. Please don't send any spam, right? All right, cool. As you see, it already sent me a verification code. I also didn't have to code this. This flow is also from Amplify out of the box. I'm just opening my mail, receive the code, and allow. Right, so now I'm in, and all this flow was provided by Amplify. So again, no code. Let's have a look then. For the AI part of this, I didn't want to have AI just generate any content for my application. So I wanted to have control of what's generated, and so I can validate and not have, for example, some data that I don't want to be provided for the users, for example. So for that, I created some sort of content management application. But first of all, I will extend the rights for this user. So I'm able to actually modify the records and generate the content. So I'm going to add this group to this user to the admin group. Okay, so I just create the user available, and edit. Cool. Going back to the console, and then let's create some content. Right, so the first thing here for a travel application that we need is like the destinations, right? Here I'm just having a prompt to ask ChatGPT, okay, please provide me a list of all the countries around the world and provide me this in the JSON format. I hit generate here, and then I have the list of all the countries in the world. So the first step, I accept it. Oh, I forgot to reset my server, just a second. There we go, just a second. This is my, wait, can't see, too big. Yeah, good idea. There we go. Right, so because I restarted the service, I guess I could. All right, that's it. So here I have a list of all destinations, and then let's say I want to generate some content for Argentina, for example. Then I basically have this chat component which I can interact with. And the nice thing here, for example, is to collect things like more complex, like this JSON thing here, where basically I can retrieve things like GPS information for this destination, what are the languages spoken in this country, currency code, population, and so on and so forth, just to see how these models can actually provide me with accurate data. Or things like what are the top artists in this country, which places I should go to, what are the top destinations inside of this country, and so on and so forth. And then I have here everything generated for me, which I can validate. I can change if I don't like. I can change the prompting, and then basically have better outcome, because the quality of the data actually depends also very much on the quality of your prompt, right? So let's just do the same for all the destinations. And then here, if I just refresh the application, then I basically have everything created for me. I have some overview. I have, because I have the GPS coordinates, for example, I have the locations that I can integrate with services like Map, or I can check weather forecast for this destination, and so forth, and I can have all these things. But also, because AWS also provides a lot of different services, for example, based on machine learning, I can also have this text translated very quickly, like in 1 minute, to 75 different languages. So I don't need anyone to translate this data for me, and actually the translations are quite good. And I can show that as well. But basically, this is one of the things you can do, right? So this is like the second easiest case that you can do besides a chatbot. But it's just to show you actually what things you can do actually when you integrate these things with your own data and generate forecasts out of it, or generate some summaries out of it, right? Imagine that you have log files, and you basically want to have a summary of how many times something happened in your log file. So you have companies that actually have solutions to provide security based on that. So as I promised, I think we still have a little bit of time. I would like to show a little bit of Bedrock. In this case, I used Bedrock to just train a model based on my own data, right? So what you're going to see here is not the data from ChatGPT. And the idea is that basically use LLMs as a language interpreter. So it understands what the user wants, and then basically retrieve this information from your data. So in more complex use case, you can orchestrate Lambda functions, as I mentioned, and retrieve some information from different sources. But in this case, what I did is basically exported the DynamoDB tables to S3 bucket. And then with Bedrock, I automatically converted this to embeddings, to some vector database, for example, using OpenSearch. So this is done also just with some few clicks. And then basically you can query this data using LLMs. So just to show a quick example. And be aware that Bedrock is actually not available in every region. So you might try out, for example, Oregon in the US. And then you create these things called knowledge base and agents, right? So just show some quick example. I will just ask for a recommendation for a trip. Just to see how it behaves. And the pretty cool thing actually is that it provides some trace on how it thinks. So there is like a kind of reasoning behind that, and it knows which services it has access to and what it needs to get from the user in order to provide some proper answer. So if you check the traces output here, you can see how it should behave, that it should not provide some information, some harmful information, and it knows that it needs to ask the user some additional information to give a more correct answer. And afterwards, because it's able to query your data sources using embeddings, then it can find which records actually gets closer to the answer and then provide the answer of the final destination. So let's just say what we want here. And actually just asking me about the weather because I also trained it to say that it should give advice based on weather, on time of the year, and things like that. So it keeps me asking. It can be a bit painful. But it also, again, it depends on how specific you are, right? So here, I trained it with very raw data. So basically, I didn't modify my data at all. So it's really raw data. And I just gave like few inputs on how it should behave just for testing. And you have like traces for each one of these interactions. And of course, like here, I'm just showing the console, but you have an API that you can interact with and build your own application out of it. And you can also choose different models. Some models are faster, some models understand better what the user wants, and so on and so forth. So you really have to try it out and see what works better for you. All right, so there you go. Based on the search results, the top ski destinations in the mountains are here and here in Andorra. And if you check the traces, you can see even which documents, which parts of your documents it match to give the proper answer. So with that, you can have a feedback loop where you can test your application and see if it actually is behaving like expect and adjust and fine tune and so on and so forth. So yeah, these are the kind of things you can do. Like the services are really easy to use, so I really recommend you play around if you feel like. Yeah, and basically that's pretty much it. In this case, I'm using Cloud. Yeah, from Anthropic. So this is V2.1. But yeah, V3 is the best one, but it was not available for me. Yeah, what he's saying actually, like V3 was released like I think last week, right? And like with V3 model, it actually surpasses ChatGPT-4. So it's really amazing. I check the comparisons, and because there are these things like called hallucinations, right? When it's like when the model cannot answer something, like it doesn't know, or it just gives some random output, and you want to reduce that like to the maximum you can. And Cloud 3 really makes that very well. But also keep in mind that it's not only about, of course, like the accuracy is like one of the most important things, but you also have to keep in mind like latency, costs. So for example, you have I think Cloud Instant, which gives like immediate answer, but maybe it cannot have so much context about the conversation. And there are some models also that behave really well with multi-language. Some models don't behave so well, so you really have to like really try it out. And if you have a use case, I recommend you check here in this console. You have access to this place where actually you can either provide your data to compare the models, or you can also use the data from AWS and check how it performs. So, another question? All right. Cool. Thank you very much. Do I have time for questions? Or yeah? Cool. Anyone?
Where to talk to? Here?
Yeah.
Okay. Like you put a price tag on the Gen 2 stuff,
Yeah.
but not so much on the Bedrock stuff. Like imagine your travel app goes through the roof now and get I don't know, 5,000 requests per second. How would it look like?
Yeah, that's a very good question. So again, it's highly coupled to the model you choose. So that's the first thing. And the second thing, I would not really use for this specific use case. I would actually, if I would have to solve this in a real world, I would pre-process this data in a manner that actually I can retrieve like the most query data, for example. So it's not something that you really would want to not have control over it, because it can easily become very expensive. But again, if it's a use case where you can afford to have smaller models, for example, that would be a good option, because they are much cheaper and they answer way faster also. So it really depends on the use case. If you have use case that you really need reliability, then I would recommend you to keep it more controlled and have some sort of flow that you can review things in the backend, for example, like this content management tool, right? It's something that you would not expect. So if I can give a recommendation, is that first you try use cases where actually you would have less impact for the customer, right? Because you can use these things internally. You can to make process more efficient, or you can use it for providing more value to the customer. But I would start by trying use cases where actually you feel more comfortable with, and then you know how the models behave, and then from that you implement this for more sophisticated solutions. The microphone, right? Sorry, can you throw? Sorry, you. Yeah.
Yeah, I mean, I had like a
Yes.
small question. Okay. Let's speak like this. So, yeah, basically you showed that like you generated some stuff on the back end, and that's the key. Like you showed us first Amplify, and then you generated something on the back end. You could just hard code it. Like, where is this connection between this generative AI and Amplify? Like some sensible connection, let's say.
Yeah,
like that.
yeah, that's what I mentioned. So actually, there is no connection between Amplify and generative AI in this case. My idea here is actually to inspire you to try these things out in a way that you would be able to think about different ways of implementing some solutions where you can easily see that you have a lot of manual work that can be maybe automated. So the keys are to think about processes that make sense to automate, that are very expensive, but also to think about if AI is the right tool for solving it. So these two things. So in addition to the data, right? Because the data, as you see, it's one of the most important things. So you really have to have good quality for your data. So yeah. Anwar?
Hey, great talk.
Thank you.
My question is more about, I think, the way you trained or rather fine-tuned your model. Like, what was the process? Like, was it very similar to RLHF, or was it something else?
No, this was actually very simple and very rudimentary. So it offers actually different flexibility for you. So AWS, you can train your models using basically your own algorithms and converting this using embedding on your own and integrate with your own database, your own vector database. But what I did was very simple just to try it out. I basically just exported my DynamoDB table into an S3 bucket, so an object, and I just pointed, I created a knowledge base, and when you create a knowledge base, you basically just point the objects that you want your knowledge base to have access to. And then based on this knowledge base, you can create agents, for example, to retrieve the data from there. Yeah, so. I'm sorry, say that again? Yeah, exactly, yeah. Any more question? That was microphone.
Hi, thank you.
Hi.
This was pretty good. So
Cool,
thank you for the preparation and really nice demo. I just want to ask one question. So was there anything that you wouldn't be able to do by using another framework instead of Amplify? And if the answer is no, then in a world that we have more and more cloud agnostics, what would be the value to convince developers to use Amplify?
It's a very good question. Actually, you can do everything with any other specific language. The main reason why I try it out and I think the idea is really good is for you to not spend time creating your own infrastructure. So don't get me wrong. I'm not saying you should not know your infrastructure. I'm not saying you should not spend time learning it. But the matter is, if you want to get started and you want to get started fast and you don't have the knowledge for the infrastructure and you don't want to worry about that, then I would say Amplify could be a good choice. Yeah. If you have the time to work on that and you have the knowledge to work on that and create your own infrastructure, then do it because you have a lot of flexibility. So it really depends on basically also what you have in mind and if you are a big company or if you are just prototyping something and you want to try it fast, or if you are a solo developer and want to create a new product, but you don't want to spend a lot of time maintaining the infrastructure on your own.
Hi, thanks for the talk. I was wondering, you said you stored your data from DynamoDB to S3. Was it the embeddings?
No, actually the embeddings, they are stored in OpenSearch in this case, but you can choose in like a different, you can choose RDS and so on. So, and then AWS provisions, in this case, Elasticsearch for you. It uses the OpenSearch serverless to create the vectors. What I did with S3 was basically to just have it as a repository for my data. So if you would do that in your company, you would do it in a different way. You could have like ingestion pipelines, right? And then you can have your data in S3 buckets, for example. And then you just point to S3 buckets where it should create this technology based on, and then, yeah, you just connect it to the agent. So the data that is in S3 bucket is basically just my raw data from my DynamoDB table. Yeah. And then, of course, the embeddings are going to be created after that. And that's what knowledge base does, right? Correct. Yeah, that's absolutely. You don't have to do it. Yeah.
Encode the raw data as embeddings, so write code to actually create the embeddings, which is basically the
exactly. That's the great thing about it, because you don't have to be a machine learning engineer and have deep knowledge on how it works to create the embeddings on your own, for example, as you would do with other Python frameworks, for example. Yeah. And AWS does that for you.
Yeah, that's so to me that's the knowledge base is that, like, it just removes all of that custom stuff that you would have to write, and most people would then have like a Jupyter notebook with like doing that. I mean, that's before knowledge bases launched. That's what everyone was doing, right? They had a Jupyter notebook that they would just play, point it at their data in S3, hook that up to even external vector databases like Pinecone or.
Yeah, exactly. Actually, that's one way of doing that. But
it's a bunch of code that you have to then maintain.
Yeah. It's not so straightforward, also.
No.
Yeah.
Is it realistic in production level?
I mean, that's what people are doing in production.
Yeah.
They're not using knowledge bases. They're using like custom code to ingest data to vectorize data.
Yeah. Or is it things like LangChain and to have like this chain of thoughts, for example?
Yeah.
Yeah.
Did you try it Amazon Cube, which is also like a knowledge base?
I tried. I didn't like it. But it's a different use case, right? Basically, from what I saw, it's more like for providing something more out of the box, even. And the idea of Bedrock is like, okay, you have this flexibility to choose your model and train and so on and so forth. So
did you use Code Whisperer to generate any of the?
Yes, I also didn't like it. Okay. I mean, not because of the output, but just because of the conflicts with the IDE. Right. So when you're typing, then it interrupts you all the time, and sometimes it's annoying. Yeah. So it's not because it's not good, but it's just this difference. The workflow. Yeah, I don't like it. Yeah. But yeah, it depends on the tooling as well, I guess. So.
Yeah.
Another question?
So thank you for the presentation.
Thank you.
I'm wondering how the use case would be for the complex services. For the simple and straightforward process, for instance, the login, authentication, or registration, maybe it's very, very useful, I see. But when the business is complex and there are so many interaction with different components, how do you see the use case of this?
Very good question. So actually, the most straightforward is you're talking about Amplify only, right? So the most straightforward thing is that Amplify provides you with all these queries, mutations, and everything out of the box for your code. But if you start to have like more complexity and you need more custom logic and not only retrieval, right? And like the normal create, update, delete. Then you can also plug this with other services like Lambda. And then you can have like serverless doing the computation for you, or you can even connect this to other API, HTTP APIs, have this integrated with Event Bridge. So basically you can have, if you have knowledge and you want to do that and your use case asks for that, and then basically you can just resolve this using other serverless approach. And you can use the AppSync, for example, to post the response as like a publish. And then you have like an asynchronous process for your client. So basically you can subscribe, and then whenever you finish processing something with Lambda, then you can just publish the answer. You don't have to do anything synchronously, sorry. Another question? Awesome. I really appreciate you coming here tonight, like this late, and thank you very much.